We are still in chapter 4, diverse architectural styles. We are in the microkernel architecture style. Let's start with the kernel in the operating systems. Kernel is the core of an operating system with which control over process management, memory management, interrupt handling. It controls everything. It's like the core part of the operating system that manage everything else in the computer. It is in charge of making sure all the other components of the system work together smoothly and efficiently. Then it can call additional functionalities when required. It could be associated with a microkernel structure where the functionality in the kernel is reduced to the absolute minimum. That means everything is based on the kernel. The kernel is responsible for managing the system resource like the hardware, the memory, the CPU, and we can add many other functionalities that can work based on the kernel. Based on this fact, we can deduce that the microkernel architecture style consists of two types of architecture components. The first is the core system, which is the kernel, and the second part are the plugin components that we can add to the core system. That's why sometimes we call the microkernel architecture as plugin architecture style, because we always plug in more functionalities to the core system, which is the kernel. The core system contains only the minimal functionality required to make the system operational. All the added plugins are additional features. A well-known example that use microkernel architectural style is Google Chrome. Because Google Chrome, when you download it, it provides a minimal core functionality necessary for web browsing. After that, we can add many other features like ad blocker, like PDF reader, and many other extensions we can add to Google Chrome. This philosophy is the microkernel style or design. Another example is the VS Code. When you download VS Code, you can find the minimal functionalities that are necessary to run some programs. Then you can add many extensions to run Python, to run Java, to run many other programming languages to VS Code. So both Chrome and VS Code exemplify how a minimal and efficient core system can be extended with a wide range of functionalities, of plugins, of extensions. Exactly how a microkernel architecture operates by keeping the kernel minimal and running most service and functionality in user space. So when you add ad blocker, for example, it is added locally in your computer and it run only on your computer. Same PDF reader on all other extensions. So how the core system knows which plugin modules are available and how to get to them. There is something called plugin registry. The registry contains information about each plugin module, the name, the contract details, how to access to that plugin, remote access protocol details. Plugin modules can also be implemented as remote service accessed through REST or any other messaging interface for the core system. In this case, the microkernel architecture will be considered as distributed architecture because the core is in one place and the plugins are in other places. I'm talking geographically, so we are talking about a distributed system, distributed architecture. So when to consider this style? We consider this style when you have a tight budget and time constraints, because implementing microkernel is not costly and is not time consuming. We will implement only the core system, then we can implement the rest gradually. You can consider this style also when you are planning to release additional features later. You can start with the core, then later each time you add more functionality. Also, when you have multiple configurations based on a particular client environment, we can say that this is important. This is the main reason when architects choose the microkernel architecture. For example, an application that can be deployed on any cloud environment, let's say in the cloud, it may have a different set of plugins that act as adapters to fit the specific service of that particular cloud. I mean, we are implementing an application and we will make it available for different type of users. This user use Google Cloud Platform. This user uses Amazon. This user use another cloud, for example, Microsoft Cloud. And this app wants to work on any kind of cloud. So what can we do? We add plugins, extensions, plugin تاع Google. So تولي لهنا an extension, another extension, plugin Amazon, another extension here for Microsoft. So when the user of Google Cloud wants to use the app, he has to first install the plugin of Google so he can use the app من البلugin نتاع Google. Same for Amazon, same for Microsoft. When we have to avoid this style, when your requirement is high scalability, because all the requests must go through the core system. The core system, this is a centralized system, so it is not scalable at all. 1 star for scalability. When to avoid this system? Also, when you find that most of your changes are within the core system. Yani each time you will change the code, edit the code in the core system, not the plugins. So don't use this architecture style. Yes, it is simple to implement. Yes, it is very cheap to implement, but scalability and fault tolerance issue. Why the fault tolerance issue? Because if this system, the core system, stop working, everything will stop working. And that's all.